Okay, let's go ahead and get started. And this will be recorded, so everybody who signed up for the webinar will also get access to the recording as well as the presentation that I'm going to show here today. So I'll go through a little bit of what Praxie is about. Try not to make this too salesy. We're going to try to focus on the value propositions around AI operations, and we're going to show you some AI supporting scheduling processes in manufacturing as well. So I'll give you 4 or 5 slides and we'll go through some demos, we'll have some discussions, and then we'll wrap up. So basically Praxie got set up. I had been in SAP and other companies, and as you go around, you find that companies have some core systems and just a sea of Excel sheets, especially in the scheduling area. And there's some huge inefficiencies. 40% of the waste, according to a lot of analysts, is in this area of unstructured documentation and unstructured process. So we built Praxie as a answer to this problem, as a digitization platform that allows you to basically turn all of that sea of Excel into AI-powered productivity applications that run from AI vision to huddle boards to production monitoring to process applications across the lean from 5S to A3 to Kaizen, Six Sigma projects as well. And we also offer a full suite of lean training and process management for your team, as well as project capabilities. So all of these capabilities are built into our system, and our main business is delivering tailored solutions around whatever processes you're trying to digitize. Those are all AI powered, and we'll show you some examples of that today. So when you're delivering AI applications, and I think all of us are really trying to learn this, there's changes going on every day. I don't know about the rest of you, but I'm studying half an hour a day on everything that's coming out, looking at the newest AI models, looking at the blogosphere and what they're saying about the new models. It's very confusing, but Praxie's name means the practical application of knowledge. So we try to break this down to say, how do we practically use AI? And the reality is, if you're going to try to build and drive AI solutions that can automate huge amounts of the workflows and give real productivity, you have to go through a process. And the existing solutions that are available for building applications on the models are incredibly cutting edge, but the ability to build applications on them is really quite out of date. These are all SQL-based systems. And basically, to build those applications, you have to go through a process of data acquisition and ETL, which is cleansing the data. A lot of information says that this is about 60% of the time of these projects. You also have to do the analysis and the logic with AI and then build that into an application that actually functions for a process. Every AI solution is really just an automation and an analytical support of a process. The reality is this takes a huge amount of time and money to get done. And so most of us are just not doing it yet. Everybody's trying to figure out how to use ChatGPT and OpenAI and other models. That is the core use case currently. Praxie has a unique model. Our system is based on NoSQL database, and what that means is it's schemaless, and it allows us to bring in data without complex transformation processes. We then normalize that data into what we call a materialized view. Think of it as a giant text grid that allows us to then use that very efficiently for AI. We then can very rapidly build applications. So for a tenth the speed, 1/10 the cost, we can get these applications to your teams and have them drive really useful applications. So those applications, I think, kind of fall into 2 categories. One we call analytical operations, which is basically doing analytical work. It might be around your scrap or your quality, or it might be around your pricing, it might be around your materialize, it might be around your scheduling, and those do analytical and operations, and I'll show you that. And then there's what most of the market is driving, which is what I call process improvement applications that really drive productivity. They're sort of the kinds of stuff you see in ChatGPT. We'll summarize information, we'll build work projects and things like that. It's quite trivial in its technological impact. It can be quite useful to optimize workflows, but in my view, it's really where a minor part of the value is. So basically what we do at Praxie is help you move from this chaotic environment into these processes. So I'm going to pause here and jump in for a demo of our updated analytical operations application. So what you see here is what we call the inquire process. And this is a framework. Think of this as a data analyst in software around any particular problem or area that you're trying to drive. You might have a yield problem in your product, scrap, et cetera. You might have a pricing you're trying to normalize, for instance, pricing across multiple segments and different product lines, hundreds of product lines. You might be trying to do scheduling. These are the kinds of things that a process like this can manage. So we call this the inquire process, and you'll see here, zoom in slightly. So you'll see that first thing you do is ingest the data. We can connect with systems via APIs, via SQL connectors, or just drag your Excel or CSV files into the system. So you acquire the data here, and what this does is the system then does an analysis of the data. You'll be stunned, and I'll show you some examples of the impact of this analysis, but the AIs do a particularly good job at understanding what the data is. In addition, you might then go into the narrow process, the ingest process, the second phase, which is providing a bunch of context. I'm this kind of a manufacturer or business. Here's the process I'm looking at. Here's my day-to-day steps that I go through. This is really quite useful in helping the AI understand the process and how to optimize that. What happens then is based on, you click this button, based on that information, the AI will generate a list of questions that you can ask the data. What's really powerful about this is it finds questions that you might not have asked. We were working with a customer in pricing, and the system brought up a number of questions around their supply chain. It was telling them which suppliers were doing move in and move out dates. Supplier scorecards is another thing that it can drive. So it generates these lists of questions. You can then select from that list of questions, or you can enter your own and add those questions to your branches of inquiry. We think of this as kind of a tree structure laying on its side, where you can have as many branches as you want. This is where it gets really, really interesting, as these branches of inquiry will then answer the question that you've decided you want to focus on. And you can see here, based on the data that was brought in, and this is just a general production data set from an ERP system. And you can see that the system is analyzing the downtime and its labor hours, the defect rates, et cetera. And so you can see it's doing quite a detailed job in the analysis. You can then add additional direction to that analysis and regenerate it. And so now you've got an analysis around that question you're asking and the answers. You can then go to a root cause analysis to better understand the process. So in this case, looking for correlations between safety incidents and production metrics and downtime. And so the system looks at the three main areas in the data that are causing that problem. Will generate you a Pareto chart about which are the standard processes or which a standard process Pareto chart that shows you where the majority of the issues are, where the impacts can be gathered. You then go to the ideate process. So the AI is actually looking at those processes and giving you best practice suggestions on the things you can do about what the data is telling you. So think about that. You've got an AI. It's not a BI tool just saying, here's your numbers. It's actually analyzing the information. It's providing a root cause analysis. It's then providing best practice suggestions. So it really enhances the team. You'll see here, it's providing some numbers based on the size of manufacturer you are on an estimate of the cost to go implement reduced downtime, equipment effectiveness, or investigate root cause analysis, et cetera. You can then run simulations, financial simulations on implementing these. And in this case, it's saying a root cause analysis one. And what it does is over a 12-month period, estimate the amount of money that you would need to put in, what the return on investment is. And you can see it, the system believes this is a quite rapid return on investment, 3 months or so. It also, by the way, will generate the core KPIs that you should be tracking around that particular problem. So if your team doesn't know what those are or how to do that, it will help them generate those. And then it generates a project plan to go execute that particular process. And then you can promote this question, effectively this analytical process, into your ops center. And it will generate, based on the KPIs you select, which KPIs you should be tracking. And you can then enter this data manually in this case, or we can connect it to your data sources so that it comes in. And now you're starting to take what your data is saying your actual core problems are, and move that into an analytical operational process where you're tracking the KPIs, you're tracking the action items. You can either you can even build automations to say, I want notified if my scrap rate goes above X or my defects go above X. And this is quite easy for us to do, to build automations that are AI managed and triggered and workflow managed, so you can generate A3s or whatever you want to do to address those issues as quickly as possible. So that's the analytical operations aspect of it. And I just wanted to give everybody a quick update on that. The next things that we're working on, which is really quite powerful, is the scheduling. And so I'm going to show you this application in a second, but a large number of our customers, and I would say probably most of us have seen across manufacturing, the scheduling is often handled by one or dozens of spreadsheet experts who are really dealing with this problem because it's quite unique and the constraints are quite unique at each company. I'll bring George in here just to talk about some of these production scheduling issues. From a computer science standpoint, these are called MP complete problems. I did not know that until recently, but it's basically a packing problem, very similar to if you have a piece of plywood and you're trying to cut out specific shapes. There's, in that case, a two-dimensional constraint, but then you add more and more and more constraints onto the problem. And programmatically and computationally, the systems become bogged down. Those of you who've used scheduling programs know that they take, generally quite a long time to churn. And the more constraints or variables you add into it, the larger and larger they get. So this is a very complex problem. And so we've done a lot of work to optimize that and using AI in that. But I'll walk through some of these and then George, jump in and comment. These are some of the things that are part of the constraints that you run into and the issues around scheduling. Machine downtime, unexpected equipment failures, things like that, estimated 10 to 30% cost, material shortages. Is the inventory there, the materials there? Those can impact 5 to 20%. Labor shortages. Do you have enough people on the line? What are your constraints around that? 10 to 25% of costs. Inaccurate demand forecasting. So, this is a broader demand forecasting, which is a part of a lot of ERP systems. Can cause a big problem. Complex product mix. Yeah, we're dealing with this as we're looking at scheduling processes for different folks, how they have different product mixes. Those different product mixes have variable times based on the different numbers of parts, et cetera, or lines those have to go through. It adds a huge complexity to the scheduling process. You also have changeovers. Are you running SMED processes? Do those changeovers, are they optimized, and how often do they happen, and how does that affect constraints? Supplier reliability, regulatory compliance, costs, and then this last one, capacity constraints. Limited capacity, and that might be labor, but it also might be machines or stations, et cetera. So this means that scheduling and MRP is built in. George, do you have any comments on these, based on your experience, where the biggest pains lie?
Yeah, a couple of comments. One, this is generally called the theory of constraints problem. There's a famous book in manufacturing called The Goal that was written about it. And his main point of the old book was to find the one constraint that you can use to match demand to production instead of just making as many things as you can. Just in time, if you realize why does it work? Because you demand all of your vendors to live to an absolutely fixed schedule. Why? Because if anything happens in the world, like there's a snowstorm, the whole JIT thing is moot, right? So why is that happening? Because we don't have systems that can dynamically react in real time to a change in a variable. If you look at most of the MRP systems, they run batch, they take hours. There are a couple of famous companies that have changed their database to allow that to run faster. The amazing thing is when you use AI to help you do the MRP, you can do it like that. These runs that Michael was just showing you take minutes. So if you want to change one of the parameters or something happens in transportation, you can run your new plan with the available stock you have in your house. With the orders, they will allow you to dynamically reorder the priority of your orders based on what is actually still coming in, and it won't take you 6 hours to run that. Or if you don't have an MRP system because it's expensive and you're trying to do this all by hand in a spreadsheet, that is eliminated by having us do this inside of an application that uses AI to do data analysis.
And what that means is that you can run these updated schedules just in time, as needed, daily, however you need to do it to optimize. Now, our view currently, and we hold views strongly but lightly, meaning that we believe in them, but we're open to changing our minds. Our view currently is that this allows you to optimize short-term scheduling very, very rapidly and do just-in-time scheduling and as needed. And we think that's incredibly powerful versus sort of long-range planning. And with this system, you can really drive out huge complexity out of your scheduling process and use the power of AI and heuristics and all the information that we can gather to really generate schedules very rapidly. Any other further comments, George? And I'll show folks an example of our scheduling application.
No, keep
Okay,
going.
so jump in here. So the scheduling application uses AI in a much lighter framework than the general analytics type of solutions you might use for, pricing or other types of analytical AI. So the way this works, it's very straightforward, is you basically build the context of your schedule. So in this case, I'm a mid-sized manufacturer making discrete products, and you can enter the different constraints you have here. This all adds context. In fact, the AI will generally find a lot of that information out of the data itself. The data we're looking at here is 3 different data sets that are, for instance, showing routing and the different types of tabs you'll often see in a scheduling system. So what we do is we're bringing that data in, and you'll see here that I'm going to jump in and open one of the existing schedules. This takes 4 or 5 minutes to run, so I'm not going to run it during the demo. But basically, you import by going and just selecting where the data is coming from. And those 3 CSVs from the standard scheduling constraints, which can be exported from the from your ERP. We also have webhook capability or SQL connectors, or we can use a REST API to pull the data dynamically. But the data comes in here, you generate the schedule, and what it's doing is based on the constraints and all the information, it generates the best possible schedule. And you can see here that this is the month and the start and end day of these. These are actually fairly large products going through the process. So the schedule can then generate that and export that right back into your system and synchronize that with your ERP. So I'm not going to spend much more time on it, but it's that simple. We build the engine that understands the different context of your constraints. We look at the data, we then run the application, and we optimize it to your exact output. And in fact, what we'd like to offer is, if anybody's interested in that, beyond trying to do that all in an online demo here, is we do in 2-week intelligent operations pilot, where if you want to provide your data, we sign NDAs, et cetera. And then if you want to provide your data to a scheduling process or any other analytical process, this is a free of charge offer. But within 2 weeks, we'll have an example of the information and the kinds of value you can get from that. And our experience so far is that the value proposition is extraordinary. You can get your ROI in literally just a couple of months for the ultimate value of operating this. And it's not just a one-time value proposition. That's the ability to analyze and optimize, let's say, your error reporting, or your quality issues, or your pricing, or your et cetera. Scheduling becomes a dynamic solution that is part of an ongoing continuous improvement process. So there's huge ROIs on this. We'll provide this as part of the downloads, and we'll send this out to everybody who was on this webinar. But if you'd like to contact us and discuss this and how AI works generally, or how we can apply it to some of the problems that you're facing in your plant or business, please reach out to me via email, or you can go to our website and sign up for a demonstration meeting directly on the site. One of our team members would be happy to talk with you and go in depth around these things. So that I'll pause and stop and answer any questions or discussion items anybody has. Yeah, any questions, follow-ups, just type them into your chat. Looks like Abini, you raised your hand. You want to just type in your, let me open up my chat. There we go. No worries. All right, with that, we'll wrap up today. And thank you, everybody, for coming. And we'll get this information out to you, and look forward to speaking with you. Thanks so much.